So this is my day 2 of placement preparation. Yeah, obviously it's a day 2 placement preparation and day 2. And in this video, I will try to
Device disconnected.
I will try to learn machine learning concepts like machine learning interview questions. Okay. So what are various concepts in machine learning? So in machine learning there are various concepts like supervised learning and then unsupervised learning, supervised learning, unsupervised learning. If you know the answer of this supervised unsupervised learning, then it's a very important one. Supervised learning, you have a data set of y and x, various level data set, and then you train your model on these data sets. In unsupervised machine learning, you have data set, but you don't have a labeled data set like y is equal to x. Okay, so this type of structure is not there. So in this model itself had to train and find a pattern. So this is differentiation between supervised learning and unsupervised learning. There is another type of machine learning also there, which is known as reinforced learning. In this reinforced learning, model itself learn like a child. Like how child learn by trial and error methods. Same way on reinforced learning model also learn. So in supervised machine learning, there are various models you have to learn. In supervised machine learning models, you have linear regression, which is y is equal to mx plus c. Then you have SVM, support vector machines. Then you have various types of उसके बाद से logistic regression is also a very important type. So in linear regression, you have a format of y is equal to mx plus c. In logistic regression, you have a 1 plus e to the power minus x. This is our model format. In SVM vector machines, let's say we have data set, then this is our SVM machine, this is our SVM model. So SVM is generally used for classification, and also it is used for regression, but very common in classification problems. Okay, so if the data is 2D, if 2D data, then SVM is a line. But if data is 3D, then SVM is a plane, because in plane you can differentiate 2 points. Okay, so this is our SVM. And after that, in logistic regression, the model is like that, this type of model. In the above one, you have 1 in the, and then 0 1. So the logistic regression will, if x is greater than 0, if x is greater than 0, x is less than 0. So if x greater than 0, then your model is returning yes. Okay, so logistic regression is generally used for cancer detection, or obviously like binary detection. This is a binary classification problem. So classification is of 2 types. So first one is binary classification, and the second one is multi classification. These are both in binary classification. You have yes or no, this type of answer, 0 or 1. In multi classification, you have multiple class. So this you have to predict using classification models. So what are evaluation metrics in classification? So evaluation metrics in classification is 0 1 0 1. So this type of matrix, here you have positive, here you have original true and false, here you have predicted true and false. Okay, this is and this is known as confusion matrix. In confusion matrix, you have precision, then you have recall, and you have F1 score. So So these are the techniques by which can you can see the evolution of your model, that model is performing better or not. If these matrices are less, then you should change your model, or you should train your model. And then there is a term which is known as overfitting. What is overfitting? So overfitting is when your model overperform, like training accuracy is very high but not testing accuracy is low. Then you can say your model is very overfit. So how to reduce overfitting? So reduce overfit, you perform various methods, like in overfitting you can use PCA techniques to for reduction of dimensionality. Then you can use regularization techniques like L1 regularization, L2 regularization. Okay, so L1 is lasso and L2 is ridge. So in L1 you add extra term in loss function, a lambda, and the term is square, and the ridge regression you do modulus. So this ridge regression will decrease the dimensionality. Okay, so this regularization technique is used. Okay, then you can reduce your features, you can do feature engineering, you can do feature selection. Like in feature selection, keep the important features which are very on which the model training is very dependent, and remove the extra features which are of no use. So okay, in feature engineering you can combine two in feature engineering you can combine two features and create a new one. Okay, so these are basic and okay, so these are basic questions any interviewer can ask. Okay, so first of all, what is machine learning? So in the field of AI, where system learns patterns from data without being explicitly programmed. And type of machine learning, then there is various different type of machine learning, like supervised, unsupervised, and then reinforcement learning. There are three types of machine learning. And in supervised learning, what we have is learning with labeled data. So in supervised learning, we learn from a labeled data. So model learn from labeled data. In unsupervised learning, okay, in supervised learning we have various models. In supervised learning we have various models like linear regression. We have linear regression, then we have logistic regression, then we have decision trees, then we have SVM, then we have random forest. So these are examples of supervised machine learning. And what is unsupervised learning? In this model try to find patterns. Patterns from the labeled data, which is also very important. Okay, examples of unsupervised learning is k-means, hierarchical clustering. So first one is k-means and the second one is hierarchical clustering. and then after that PCA. Then we have autoencoders. So what is reinforcement learning? So reinforcement learning is where agents, okay, so in reinforcement learning where agents learn by, here model, here model learns by interacting environment and maximizing rewards. So and after that we have a term overfitting. So what the meaning of overfitting? So overfitting means when model fits. So in the overfitting, what is overfitting? When model fits too much on training data, when model fits too much on training data but fails to generalize, okay, but fails to generalize. So this is called as overfitting. And what is underfitting? Underfitting is when model is too simple. So underfitting is when model is too simple. When model is too simple to capture. Okay, when model is too simple to capture the data patterns, then you can say it's underfitting. It's an underfit model. So how you can prevent overfitting? So for preventing overfitting, we can use various methods, like we can use regularization. Then after that we can use dropouts if we are using deep learning models, and then after that you can use early stopping in deep learning. These both are in deep learning. Early stopping means when your accuracy or your evaluation metrics doesn't improve a lot, then you can stop your model earlier. Okay, this will improve your training time also. Okay, then we can use cross validation for generalizing our model. In cross validation, let's say we have a data set, then we divide our data set into multiple subsets, and then in the first iteration we use this as a validation data set, and in this we split train test data set, and in the next iteration when we come, then we use this as a validation data set. In the next iteration we use this as a validation data set. So this is our common pattern in cross validation, and this is for generalizing our model. Yeah, okay. And also we can give more data to model to train. So these are various techniques: the regularization, dropout, early stopping, and cross validation. And this about the techniques which we can use for reducing our overfitting. And okay, and then there is a term which is known as bias variance trade-off. So what is bias variance trade-off? Okay, we have bias variance trade-off. So what is bias variance trade-off? So in bias variance trade-off, it is a balance between overfitting and underfitting. It is a balance between overfitting and underfitting. Okay. Okay, then we have cross validation. So what is cross validation? In cross validation, we split our data into folds for training testing multiple times for robust evaluation. So what we do in, we do splitting data. Okay, splitting data into folds, splitting data into folds for training, splitting data into folds for training, testing multiple times for robust evaluation. Then we come as regularization. So regularization is a technique which we generally use for reducing overfitting. So in regularization, what we use is adding a penalty to model complexity. So what we do, we add a penalty. Add a penalty to model complexity. Okay. So why our model is overfit? Because our model is too complex. So for that reason, we add a penalty term for model complexity, and there is two type of this. First one is L1, which is also known as lasso, and the second one is L2, which is known as ridge. Okay, then there is a term which is known as gradient descent. So what is gradient descent? So it is an optimization algorithm. It is an optimization algorithm. Okay, so what is gradient descent? So it is an optimization algorithm to minimize loss by updating parameter. So okay, so what is gradient descent? So gradient descent is it is an optimization algorithm which is used to minimize, which is used to minimize the loss function by updating parameters. Okay, so step by step. So this is known as gradient descent. So gradient descent is an optimization algorithm which is used to minimize the loss function by updating parameters step by step. Okay, so there are many variants of gradient descent. So in gradient descent we have many variety, like one we can say batch gradient descent. Okay, then we have stochastic gradient descent. Then we have mini batch gradient descent. In batch gradient descent, stochastic gradient descent, then we have mini batch gradient descent. So these are various techniques of gradient descent. These are all used for minimizing the loss function. And how they minimize the loss function? By updating the parameters. This is the way how they reduce the loss function. Then after that we have confusion matrix. In confusion matrix, the table show true positive, true false, false positive, false negative. Okay, then we have precision. The formula of precision is true positive upon true positive plus false positive. Okay, true positive upon true positive plus false positive. Okay, and then recall. In recall we have true positive upon true positive false negative. Okay, so what is F1 score? So F1 score is 2 P R upon P plus R. So this is known as F1 score. So it is a harmonic mean between precision and recall, which balance the both. Okay, so then next time we have ROC AOC. So what is ROC AOC? So ROC AOC measures classifier performance across thresholds. So ROC AOC measures classifier performance across thresholds. So it measures classifier performance across thresholds. This is known as ROC AOC. Higher is better. Then after that we have dimensionality reduction. Dimensionality reduction and we have dimensionality reduction. In dimensionality reduction we have okay, so what we do in dimensionality reduction, so we reduce the number of features, because when there are more number of features, then it is very difficult to train the models. So that's why dimensionality is also occurs. So what we do feature engineering, feature selection, and reduce our features by combining various features into one. Now there are various methods we can use, like we can use PCA, then you can use TSNE. So these are the methods by which we can reduce our dimensionality. Okay, then we have a feature scaling term. So what is feature scaling? Okay, so in feature scaling there are normalization and standardization of features to improve model performance. So in feature scaling we have normalization, then we have standardization. So these are the methods. Of features to improve the model performance. Obviously these are the methods by which we can improve our model performance. Okay, then after that we begin with bagging and boosting. So in bagging, let's say we have a data set, then we divide our data set into multiple subsets, and then train a model. This is model 1, this is model 2, this is model 3, and then this is model 4, and then combine this all into a single model, and this is known as this method is known as bagging. Example of bagging is random forest. And then we have a boosting model. So in boosting we have serial series of models. Like this is model 1, and this model is trained on the whole data set, and after that this model have some errors. So the model 2 tries to minimize the errors of the model 1, and model 3 tries to minimize the error of model 2, and then model 4 tries to minimize the errors of model 3. So this is the technique of boosting. In boosting we have various models like AdaBoost. AdaBoost equals boosting. Okay, another one is XGBoost. Then we come with ensemble learning. So what is ensemble learning? So ensemble learning is a combining multiple models to improve accuracy. So ensemble is basically these are all the above. Like this is model 1, this is model 2, combine this model and try to improve our accuracy. So this is known as ensemble learning. Ensemble learning. Then we have KNN. So what is KNN? So KNN is instance based algorithm. What is this? This is instance based algorithm. And what is instance based algorithm? So classifier that finds the optimal hyperplane. No. So what is KNN? So KNN is an instance based algorithm, predicts using nearest neighbors in the feature space. So this is known as KNN. So KNN means nearest neighbor. So it predicts using nearest neighbor. Predicts using nearest neighbor. In feature space. Then after that we have SVM. So what is SVM? SVM classifier that finds the optimal hyperplane, maximize margin between the classes. So let's say we have a class of XXX, and then we have a class of circles. Then this is our plane or line, and then try to maximize this margin. This is our margin, and then we try to maximize this margin. So this model is known as SVM, and it is basically a classifier that finds the optimal hyperplane. Okay, so this is a classifier that finds a hyperplane. Okay, after that we have naive Bayes. What naive Bayes do? So in naive Bayes, probabilistic classifier using Bayes theorem. Okay, so this is a probabilistic classifier. Okay, so this is a probabilistic classifier. Used Bayes theorem. It uses Bayes theorem, and it also assumes that features are independent. that features are independent. So naive Bayes, it is a probabilistic classifier. Then we have use Bayes theorem and assume that the features are independent. So in Bayes theorem we assume that features are independent. Then we use Bayes theorem to predict a model to predict. Okay. After that we have neural networks. So obviously neural networks are inspired by. Okay, then we have neural networks. Neural networks are inspired by brain. Neural networks are inspired by brain. Obviously, like this is a simple neural network. Here we have input and these are the hidden layers, and then we have output. So these are the outputs, and we have CNN. So CNN is convolutional neural network used for image regression. Used for image recognition. So this is CNN. Okay, full form is convolutional neural network used for images. Okay, then comes RNN. So RNN is recurrent neural network. So what it does, it handles sequential data. So RNN does sequential data. Like text, like time series. Then we have transfer learning. So using pre-trained model on new task to save time, and so transfer learning is using pre-trained. So transfer learning is very important. Okay, in transfer learning what we use? We use pre-trained model. Okay, so these are So these are the email questions, general email questions which companies ask. So try to learn this. Yeah, and this is very important. If you are not good in communication, it will then create a channel, create a YouTube channel, and try to speak in front of the camera, in front of the you can, if you don't want to, uh, speak in front of the camera, then you can use my method, like I am using my tablet to teach you guys, because that's very important in an interview. If you are not able to communicate your answers, then that doesn't matter. It doesn't matter you have solved the question or not, but if you are not communicating well, then no matter what you are doing, you are doing it in the wrong way. So try to improve the communication. That's the most important thing you can do. Yeah. So my name is Himanshu Yadav.